inflection points and concavity. Look at the graph of this function. Okay, look how the graph travels. If you look from here to here, the graph is concave down. Concave down. Over here, suddenly the concavity changes and it turns concave up. This point here is called an inflection point. What does it mean to be concave down? What this means is that if you were to take the second derivative at any point on the x-axis in this region over here, the second derivative would be negative. What does it mean to be concave up? To be concave up means that if you were to take the second derivative at any point in the x-axis in this region over here, except this point over here, it would be positive. This point is an inflection point because the second derivative at this point is 0, and if you move to the left of it, the graph is concave down, and if you move to the right of this point, the graph is concave up. Let's look at another graph. Okay, so here we have a situation where the graph is concave down, concave down. Here we have an inflection point. Then the graph turns concave up, concave up, concave up, concave up. Oh, by the way, this over here corresponds to a critical number. What does it mean, a critical number? Well, it means that the first derivative here is 0. The same thing up here. Okay, let me make this a little bit bigger. Okay, and move it down a little bit more. Or rather, move this up a little bit more. Okay, perfect. Okay, so concave down, the second derivative is thus, okay, for any value x that corresponds to this region over here on the graph is going to be the second derivative for any value x that corresponds to this region here is going to be negative. Inflection point, the second derivative here at this point, at the x value corresponding to this point, would give you 0. If you move to the left of the x value, the graph goes from being concave down to being concave up after this point over here. Alright, so concavity is a very useful concept, and it can be identified graphically with a picture of a graph, and this is an example of how we do that. So before I go, actually, let me say that notice that this, from here on, the derivatives of this function are positive. So this function is increasing, okay, for x values, let's say between here and here, okay. The same thing happens here. The first derivative is positive because the tangent lines are pointing towards the sky. Here the tangent lines are pointing towards the earth, so this function is decreasing, okay, for x values corresponding to this region.